I am 2/5. At first, I may look like a small symbol, a 2, a line, and a 5, but I am not just a symbol. I am a value. I am a part of a whole, and my meaning begins with the 5. The 5 tells us that one whole must be split into 5 equal pieces. Each piece must be the same size. No piece is allowed to be larger. No piece is allowed to be smaller. Then the 2 tells us how many of those equal pieces are chosen. So I am 2 chosen pieces out of 5 equal pieces altogether. That is 2/5. Now we can see the whole more clearly. The whole is one complete bar. The bar is divided into 5 equal parts. Then 2 of those parts are chosen. So the shaded amount is 2/5. The unshaded part is not ignored. It reminds us that the full whole is still all 5 parts. This matters. A fraction is not only about the pieces we choose, it is also about the whole those pieces came from. 2/5 means 2 selected parts, when the whole has been divided into 5 equal parts. Now the same value changes its body. The bar can become a circle. The shape is different, but the fraction must keep its meaning. The circle is still divided into 5 equal parts. 2 of those parts are still chosen, so the value has not changed. It is still 2/5. The bar and the circle are different forms, but they are describing the same amount. Now 2/5 becomes a position. Think of the journey from 0 to 1. That journey is one whole because the denominator is 5. The journey is split into 5 equal steps. Each step is 0.2. The numerator is 2, so we move 2 steps from 0. 1 step lands at 0.2. 2 steps land at 0.4. So 2/5 is the same position as 0.4. The bar, the circle, and the point on the number line all meet at the same value. Let that idea settle. 2/5 can appear as a fraction. It can appear as a bar model. It can appear as a pi model. It can appear as a point on a number line. It can appear as the decimal 0.4. The form changes, the value stays fixed. Now we begin equivalent fractions. We start with 2/5. The bar has 5 equal parts. 2 of those parts are shaded. A scale factor appears. Times 2. The numerator is multiplied by 2. The denominator is multiplied by 2. So 2 becomes 4. 5 becomes 10. Every fifth has been split into 2 smaller equal pieces. The whole now has 10 pieces. The shaded amount now covers 4 of those 10 pieces. So 2/5 becomes 4/10. But notice the important part. The shaded endpoint has not moved. The value is exactly the same. Only the number of pieces has changed. So 2/5 equals 4/10. Now we continue from 4/10. Apply the same scale factor again. Times 2. 4 becomes 8. 10 becomes 20. The bar now has 20 smaller parts. 8 of them are shaded. So 4/10 becomes 8/20. And again, the shaded endpoint stays in the same place. So 2/5, 4/10, and 8/20 are all different names for the same value. They look different. They use different denominators, but they represent the same amount. Now we reverse the process. 8/20 has many small pieces. That can be useful, but it can also be simplified. We divide the numerator by 4. We divide the denominator by 4. 8 divided by 4 gives 2. 20 divided by 4 gives 5. So 8/20 simplifies back to 2/5. The value has not become smaller. The pieces have simply been grouped together. That is what simplifying does. Now we compare 2/5 and 3/7. At first, they are difficult to compare directly. 5ths and 7ths split the whole in different ways, so we make the comparison fair. We use a common denominator. For 2/5, we multiply by 7. 2 times 7 gives 14. 5 times 7 gives 35. So 2/5 becomes 14/35. For 3/7, we multiply by 5. 3 times 5 gives 15. 7 times 5 gives 35. So 3/7 becomes 15/35. Now both fractions use 35. 14/35 is less than 15/35. So 2/5 is less than 3/7. Now the same idea moves a little faster. 3/4 becomes 6/8. The top is multiplied by 2. The bottom is multiplied by 2. The value stays the same. 5/6 becomes 10/12. Again, the numerator and denominator are both multiplied by 2. The pieces are smaller, but the shaded amount is unchanged. Now we simplify. 12/18 can be divided by 6. 12 divided by 6 gives 2. 18 divided by 6 gives 3. So 12/18 simplifies to 2/3. 15/20 can be divided by 5. 15 divided by 5 gives 3. 20 divided by 5 gives 4. So 15/20 simplifies to 3/4. Now we compare 3/4 and 5/6. A common denominator is 12. 3/4 becomes 9/12. 5/6 becomes 10/12. 10/12 is greater than 9/12. So 3/4 is less than 5/6. Now compare 4/9 and 5/12. A common denominator is 36. 4/9 becomes 16/36. 5/12 becomes 15/36. 16/36 is greater than 15/36. So 4/9 is greater than 5/12. The rule is calm and reliable. Make the pieces the same size. Then compare how many pieces are shaded. Now, one more comparison. 7/10 and 2/3. The denominators are different. Tenths and thirds do not cut the whole into the same kind of pieces. So we make a common denominator. 7/10 becomes 21/30. 2/3 becomes 20/30. Now the pieces are the same size. 21/30 is greater than 20/30. So 7/10 is greater than 2/3. Now the method becomes familiar. Now we meet a fraction larger than 1. 7/4. A quarter means 1 out of 4 equal parts, so 1 whole is 4/4. 7/4 means we have more than 1 whole. 4/4 make 1 whole. After that, 3/4 remain, so 7/4 is 1 3/4. The improper fraction has been reorganized into a mixed number. The value has not changed. It has simply been written as wholes, with a fraction left over. Now another improper fraction. 11/5. 5/5 make 1 whole. Another 5/5 make a second whole. That accounts for 10/5. 1/5 remains, so 11/5 is 2 1/5. The number line and the bar model agree. 2 whole groups and 1/5 left over. Now we travel in the other direction. 2 1/5 becomes an improper fraction. 2 wholes means 2 full groups of fifths. 5/5 plus 5/5 plus 1/5. That gives 11/5. So 2 1/5 equals 11/5. Now look at the pattern with 3 2/7. The whole number is 3. The denominator is 7, so each whole contains 7/7. 3 wholes means 3 times 7. That gives 21/7. Then we add the numerator, which is 2. 21 plus 2 gives 23. The denominator stays 7, so 3 2/7 equals 23/7. The pattern is whole number times denominator, then add the numerator, then keep the original denominator. Now, fractions can also be negative. Start at 0. Positive 2/5 moves to the right. Negative 3/5 moves to the left. The step size is still fifths. The minus sign tells us the direction, so negative 3/5 is 3/5 to the left of 0. Now look carefully at the minus sign. Negative 3/5. Negative 3/5, 3/5. These all represent the same negative value. The minus sign can move, but the value stays the same as long as there is only one negative sign. Now it is your turn. Pause the video when the question appears. Try it gently, then continue when you are ready. First question, 2/7 equals what over 28? We begin with the denominator. 7 must become 28. 7 times 4 gives 28. So the denominator has been multiplied by 4. To keep the fraction equivalent, we must do the same thing to the numerator. 2 times 4 gives 8. So the missing numerator is 8. 2/7 equals 8/28. The bar model confirms it. The pieces are smaller, but the shaded amount is the same. Next question. Convert 1 3/4 into an improper fraction. 1 whole contains 4 quarters. Then there are 3 more quarters. 4 plus 3 gives 7. The denominator stays 4. So 1 3/4 equals 7 quarters. The whole part gives 4 quarters. The fractional part adds 3 more quarters. Altogether, there are 7 quarters. Final question, convert 9 quarters into a mixed number. 4 quarters make 1 whole. Another 4 quarters make a second whole. That uses 8 quarters. 1 quarter remains, so 9 quarters equals 2 1/4. 2 complete wholes and 1 quarter left over. And now the story comes together. A fraction can be a symbol. It can be a bar. It can be a circle. It can be a point. It can be a decimal. It can be scaled. It can be simplified. It can be compared. It can be improper. It can become a mixed number. It can even move to the negative side of 0. But through every form, one question matters most. Has the value changed, or has only the form changed? When you can answer that question, fractions become calmer, clearer, and far more powerful.